I've done last few lessons, guys. Let's get down to it, and then as soon as we're done, we can start reviewing. Okay? So what I'm going to do, I'll tell you. Okay, so as stated, the main reason for differentiating is to find the gradient of a function. Okay? Now, some of the questions I did set yesterday, I was like set you off merrily. It did say find the gradient when x equals so and so. And that's what we're talking about here. So once you have the derivative, so remember this is the fancy word for the dy dx or the f dash x expression. So once you have that derivative, you may be able to calculate the numerical value of the gradient. Okay, so they may say, what is the gradient when x is 7? What's the gradient when x is 1? What's the gradient at the point, blah, blah. Okay? So all you have to do is find the expression for the gradient or the derivative and then substitute that value into it. That's all you have to do. So here it says, a function is given by fx equals blah, blah. Find the gradient at the point 213. So they want the gradient. So we say, haha, what I need to do is differentiate. But I'm looking at this function and thinking, oh Lord, what do I have to do with this first?
You gotta get it all so it's about powers.
Nice. Because at the moment, I have an x squared on the bottom, yes? So first things first, I'm just going to write fx because I'm not differentiating yet. I'm just rewriting it. Dinah, can you rewrite it for me, please?
6x.
Don't start differentiating yet. So literally, we're just rewriting it, but we're focusing on this term. Is that the one that's going to change?
Oh, so 2x cubed
2x cubed
minus 2x.
minus 2x
4x.
plus 4x, okay?
4x.
Need to find a friend.
Phone a friend.
Call me, maybe.
Yeah, that's fun.
What is it, -2?
Yes, it'll be -2. Can you explain to Dinah why?
Because you're bringing it to the top.
Yeah,
Or you
so,
could just do negative.
so remember, any powers that are on the bottom of the fraction, when they're put to the top, become negative.
Oh, yeah.
Yeah? That's not convention.
Yeah.
Like, do you remember when we had 1 over x is 4? This would be x to the -4.
Oh, yeah. I remember
Yeah.
that.
Good. Oh, good lord, it was 20 hours ago.
Emma.
Pardon? On. Should we open the window?
No, I don't.
Okay, so we've rewritten our question. Now we have to differentiate. So, f dash x now. But, and I'm actually a little bit glad that Dinah started to differentiate because that's what most people do. They start mixing the processes up. So you've really got to be careful that when, in the first instance, all you're doing is rewriting it and changing the 1 or 2 terms that you need to. Then you can differentiate. Okay, Jamie.
Is it 6x squared minus 2 minus 8x negative 1 equals -1? No.
You wouldn't put negative 1 there,
Next one.
but because it's not negative 1.
What? Oh, yeah, you said negative.
So what is it?
It's 8x, negative 8x, negative 3.
Good. Okay, so we've now got our derivative, but they've asked us what's the gradient at the point 213. Now, secretly, this, is irrelevant. We don't actually need to know the y value because the only thing that we're interested in, the only thing that's involved in our expression is the letter x. And so the only number that we need to know is this one. Okay? That's why some questions will have when x equals, sometimes they will give you the coordinate, but you don't need to know the y value. So all we're going to do now is substitute that value in. So, to show we're doing that, hopefully you may or may not remember in function notation, to substitute a value in, we would just write the number in the brackets. So I'm showing that 2 is being substituted for my value of x by writing it in that bracket there. So then I've got 6 bracket 2 squared, take away 2, take away 8, bracket 2 to the negative 3. Now you have your calcs available to you in both papers, so we never need to worry about not being able to put it in there. So let's chuck it in there. Remember, to a power is that button. Okay, that's to the power. So chuck it all in, use brackets where you're showing your substitution.
I got 21, but I didn't use a calculator, so maybe yeah, it's 21.
Elena. But I see Ching and we like.
I'll support it.
So that tells us that at the coordinate 2, 13, or wherever it was I crossed it out now, the gradient is actually 21. Okay? So if we were to have our graph to draw a tangent, we would find that the gradient was 21. How exciting is that?
That's sharp.
It is. Yes.
Wait, no, it's not. It's still.
Okay. Oh, there's more?
No, it was just, you filled it all in there, so it was like on the point to x equals. So then you put it all together.
Oh, see, I've got a different bit. It's okay.
Find the gradient of the curve.
Fine.
X 3 is equal to
It's okay, so
you can just cross out one side. Skip.
I'm sorry. Have you got this page? Now I worry you've got this page.
I have.
I have it.
Let's go.
Alright, okay. So, oh my gosh, this is pretty. Right, so it says, hi. Find the gradient of the curve y equals blah blah. Lily, seriously, I'm going to chuck you out in a minute. I don't know how many warnings I need to give you. So, find the gradient at this curve at the point 19. So, I've got brackets here. We don't like brackets. So, in a similar way that before we had to change our powers when there was fractions, what do you think we're going to do with this expression first? Kiara? Expand it. Perfect. So, Kiara, can you expand it for me?
21x equals 12x.
Awesome. So I've rewritten my expression. Now I can differentiate. Sabrina, would you be able to differentiate this for me, please?
Sure. Is it just 21?
Yep.
Minus 36x cubed?
Yep, x squared. Wonderful. And Shayla, what am I going to do now? Because they've specified that they want to know what it is at the point 19. Yeah, so what am I going to write now?
21 minus 36 minus 2.
Awesome. Notice I'm using brackets around my 1. So it's my 1 that's being squared. 1 squared is 1 usually, multiplied by 36, so I've got then 21 take away 36, or 21 take away 36. Oh, she's on fire today.
What is that whole thing with the
At x equals 1.
what is that?
Because they want to know at the point 19.
Right. Well, you know how we do F with the function with the y and the
So when you've got to square the x, you can't write something fancy, so that's why I wrote at x equals 1. Okay? So we're going to do a similar thing now. Shall I leave you to have a bash at some of these, and then we can come back and see if there's a right answer? Okay. Just as a heads up, we did stuff like this one the other day. Okay? And this one, I don't want you to panic that the letters are now different. Okay? The process is still going to be the same. So when we had y equals and there were x's involved, we wrote dy dx, didn't we? Now it's a big A and there's R's here. So that's why they're asking us to find dA, dr. So it's just different terminology depending on the letters.
And then if we wanted to change the terminology in the exam, would that irritate them?
You may get marks not top.
Okay.
So just be careful.
So we did the first one together. The second one. So remember that constant terms, when we differentiate, that we didn't have to do any rewriting here, but the constant term disappears. Did we all get 135? Yeah? Just be honest. Don't forget when you're substituting in negative values to put brackets around stuff, because that's when it all goes pear-shaped if you've got a squared. If you haven't had the negative sign around it in the calc, it will tell you the wrong answer. And here we had to rewrite first of all. Stick the value in, lovely jubbly. And this one, remember the lesson before, we did some where we split it. So that becomes 1 minus 4x to the negative 2. Whilst not having this one in your working stage won't affect your answer, it may lose you marks, because when these two disappear, they don't just completely disappear, you get 1. Okay, so that was just something a few of you had forgotten. You just left it as negative 4x to negative 2. And you can leave your answers as fractions or decimals. Either are fine. Okay? Okay, here's another one. P lies on the curve, blah, blah. The gradient of the curve is equal to 7. So they've told us what the gradient is equal to, but the first part says find the gradient function. That's another fancy way of saying differentiate it. Okay, the gradient function is another way of saying derivative. So that's derivative. So part A. If we differentiated this, Emily, what would we have?
We have 2y, 1, or 2y. And yes, plus, minus 0.
Okay, I'm not going to write minus 0, I'm just going to leave it, yes? So that's my gradient function. Part B says find the x coordinate of P. Wow. They've said that the gradient at the curve of P is 7. So what does that mean that we can now write? If we know that the gradient is 7 at the point P, what can we write? Elena?
Would you say that 7 equals 4?
You would exactly write that. We'd say that 7 is equal to 2x plus 3, or obviously vice versa. So the gradient is equal to 7. So we took our gradient function and put it equal to 7. Perfect. Rearranging this is going to allow us to find the x coordinate of it. So we're going to rearrange this bad boy. Rihanna?
7 goes over to 3. I mean, 3 goes over to 7, so 7 subtract 3 is 5. So then 5 is 2.
So that's equal to 2x. And then 7 take away 3 is secretly.
And it's 4.
Yes.
And 4 over to 2. And then do all that. And
I'm not 100% sure about your description, but I think we're good to go. Yes?
yeah, I know what I'm doing.
Yes. I know what it is. Just I think it's good that it's a written thing, not a verbal, because I think that would have got a little bit apart. So that's our x coordinate. Oh, I haven't actually written it. So shh. And then part C has said find the y coordinate. Well, how are we going to do that?
Use the formula of the curve.
Oh, I love it. I love it. So they told us up here that y is equal to this. Yes? So we're going to substitute this value we just found into that function. So y is equal to 2 squared plus 3 log 2. No. Take away 4. Let's just all work it together. So 2 squared is 4. 3 3 lots of 2 is 6. Take away 4 is 6. Lovely job. Okay, yes.
Can we go back all the way to the first part?
This one? So it says find the gradient function. That means find the derivative. So how do we differentiate? You know how to differentiate.
Oh, well, say that I don't, because I don't understand how you got into this stuff.
So this number comes in front, take 1 off the power.
Yeah.
So that we've got 2x.
Yeah.
And then when it's just an x, just remember it's just the number in front of it. And when there's no x attached to it, we ignore it.
Oh,
Yeah? Right, okay, I'm back to recording. Shh. So we've said that there are 2 points this time. Now the function is slightly different. Some of you didn't spot that it was different, and you merrily told me that the derivative was the same. But in this case, dy dx is 3x squared plus 3. Okay, so that's my derivative. I know that the gradient is 6 at this point. So we say that 3x squared plus 3 is equal to 6. And then going to rearrange. So x squared is 1. So when we are square rooting, at this level, remember what happens when we square root something. It's positive or negative 1. Because the square root of a number can be both the positive and the negative version. So there's our 2 x values, but they've actually said to find the coordinates. That's not a coordinate, that's just an x value. So what we're going to do now is find the corresponding y values. So we say when x is 1, y would be 1 cubed plus 3 lots of 1 plus 4.
Oh my gosh, I'm so
And
small.
when x is negative 1,
Oh my gosh, who said that?
I know, how's the fact that lady kept talking about people not being confident in maths?
Sorry.
I know it
I
now.
was like, this person, she's describing me.
So my 2 coordinates are positive 1, 8, and negative 1, 0.
Yes.
Point B is, oh, totally C, is the coordinate 1, comma B. So we don't know the B version, but we do know the x value is 1. It lies on the curve to the left. Find the value of B. Oh my god, how are we going to do this?
We put the 1 in the x.
Yeah.
Yeah.
So all we're going to do, we know that this is the x value. We have a rule to find y, so we're going to substitute it. So A, so B would be y equals 1 squared, oh, turning up plus. Darling, let's just work it out, shall we? So 1 take away 4 plus 1, which is, Jamie? Negative 2. So the value of B is negative 2. Lovely job. Then it says find the gradient function. So, Shayla, what will I do now to find the gradient function?
Okay, hold on.
What's another way of talking about gradient function? What do they mean by that?
Oh, the differentiate.
Differentiate it, yeah? Okay, this is
Oh my gosh.
Okay. So,
Do 2x,
yes.
okay, 2x minus, thank you, 4, and then the.
Good. Lovely. So we found the gradient function of the curve. There's down.
Look at this.
And then it says that show that at P, the gradient of the curve is equal to B. Now, so they're trying not to give too much away here because they've asked us to find this. So if they start talking about the value of it, then it gives it away. So what are we going to do to find the gradient of the curve at the point P? You know?
You substituted in for 1.
Yes.
Okay.
So we're going to substitute x is equal to 1 into 2 by dx. So all of these questions are very similar.
Yeah. So that's
And we've shown that that was equal to our value of b. So it's a little bit of a clue that if you didn't get -2 for part A, then something's gone wrong at some point in your work because you didn't get the same answer. Because it said show that. For D, Q is the point on the curve which the gradient of the curve is equal to -2. Okey-dokey smoky. So we know that the gradient is equal to -2. What will I do now, Dinah? If I know that the gradient is equal to -2.
-2 equals
Which part of my working shows me about the gradient? I'll give you a clue. This says the gradient function. So what was the gradient function?
yeah.
So our gradient function was
2x
2x minus 4. Yeah? So that means that this expression here tells us about the gradient. So if they told us that the gradient was -2, it means that -2 is equal to that.
Oh, yeah.
Yeah? You happy with that?
Yeah.
You all happy with that?
Yeah.
Shayna? Are you listening, darling? Are you losing it?
Yeah.
Almost at the end of the day. You know what?
I know it's the next one.
Okay, so now we're going to rearrange this and solve it. So we're going to add 4 to both sides. So we get 2 is equal to 2x. And so we get x is equal to 1. Now, that tells us the x value. In our coordinate q, which part of that was the x value? C. Okay, so we know that C was 1. How do we find D? You know?
We substituted into the
Yeah.
original.
We substitute that value of 1 into the original equation.
Why the original and not the same one?
Because remember that this 2x minus 4 talks about the gradient, it's the y dx. This is the only rule for y. Okay? So that was 1 squared minus 4 lots of 1. We've just done this already. Oh, is equal to D, which is equal to D.